It'll.
Got it. So now we are official online.
Yes. Go ahead, please. I can kick things off.
Yeah. Thank you, Jim and Tim, for having us join this meeting. So glad to be here. So my name is Kai Shu. I lead the Kubernetes team at ByteDance. Since January, Charles delivered the first session to this group. We have made a lot of progress. So if you look at the CNCF landscape, right now, Kubezoo already officially on the landscape. So that's great news for everybody. And we also have made some other update, like fix a lot of issues from the community. And this time we want to present the update mainly on the cluster resource quota implementation we have. Even though it's right now still in tech preview, but we soon will be publishing this to the open source community. That's why Lintong Yixiang, they prepare this discussion with the team and seek for any feedback before we finalize the publication shortly. So with that, just want to hand over to Lintong. You can start your presentation. One
quick question, Kaishir. So you mentioned that this is in the CNCF landscape. So Kubezoo is it a sandbox project or an incubating project or?
Right now, I think it's an incubator project. Yeah.
Fantastic.
All right. Yeah. So is it right time for me to take over here?
Yes, please go ahead, Lintong.
Okay. Yeah. Thanks, Jim. Yeah. Thanks everyone for joining. Yeah, it's a great pleasure to meet you guys in this working group meeting. So yeah, this is Lintong from ByteDance. So I'm here together with Kaishir and Yixiang from our team to give a status update for Kubezoo. So it's an incremental, we are going to present the incremental change since Charles presented early this January. And okay, so here is the agenda we prepared for this session. So first of all, we are going to give a quick recap of Kubezoo. So I think it will be very helpful for folks who are new to Kubezoo. And second, there are a few news to share with you folks. So firstly, Kubezoo was open source in late July and was just included in the CNCF landscape, I think in this month. And yeah, we improved the Kubernetes compatibility of Kubezoo. So far, Kubezoo supports Kubernetes up to 1.24. So yeah, the team has been working very hard to run a lot of performance testing and do a lot of bug fixing. And the third one is there's a new feature. Yeah, we're going to share a new feature of the cluster level resource quota management. Even though it's still something like a tech view feature, yeah, that's why you folks still cannot have access to it from Kubezoo GitHub repo. Yeah, it will be generally available very soon, so please stay tuned. And in the last part of this session, we're going to have a quick demo of this new feature. And yeah, first of all, let's have a quick recap of Kubezoo. So Kubezoo is just a lightweight gateway service for Kubernetes multi-tenancy. It presents a new tenancy model for Kubernetes. So currently, there are three main tenancy models in Kubernetes. So namespace as a service, control plane as a service, and the cluster as a service. Kubernetes API as a service presented by Kubezoo is designed to sit between namespace as a service and the control plane as a service, which enable Kubezoo to be very lightweight and also very fast, and also to provide the view level isolation just described in this diagram. Simply speaking, Kubezoo runs its own API server along with distributed key value store as its metadata storage, which would serve for the API request from inside all tenants. Meanwhile, it also serves as an API gateway with protocol conversion, which submit API requested with proper conversion to the backend API server. In terms of the tenant management, we introduced tenant CRD as the API and the tenant controller within the Kubzu server to manage all the tenant instance. The Kubzu or tenant controller will be responsible for signing certificate and generating Kubzu kubeconfig file. This is how like Kubzu give each tenant an isolated view of the cluster. So as we have already refreshed our memory about Kubzu, let's take a look at the new feature, which is a cluster level resource quota management. So currently, Kubernetes built-in resource quota is just namespace scope. So it will be insufficient to support tenancy model beyond a single namespace. So that being said, we expect the resource quota at the tenant level, which support resource quota management spanning multiple namespaces. We need so that's why we need the cluster level resource quota management, aka cluster resource quota. So it is a cluster scoped CRD, and it supports cross namespace resource quota management. And the status of the cluster resource quota will be the place to persist the aggregated resources usage in each of the namespace, which managed by the tenant. So yeah, here we're going to give a little bit more information about the key components of the cluster resource quota feature. So the same as the Kubernetes built-in resource quota, cluster resource quota also has two main components. So the admission component and the controller. So as we've already familiar with, the resource quota admission will be responsible for both quota admissible evaluation and usage updating, while its controller reconcile a quota update and recalculate the actual resource usage. So basically, it serve as a source of truth in terms of resource quota. The cluster resource quota controller, it will just keep watching for the creation of its instances, and then create one managed resource quota instance for each of the namespace with match and label as specified in its spec in the format of the namespace selector. So it's just a label. Since the creation, the cluster resource quota controller will continue watching all of this instance and keep syncing and aggregate quota usage from all managed resource quota and persist the aggregate usage in the status of the cluster resource quota. So, but in the admission part, so different from depending on the in-tree admission, as in the built-in resource quota, the cluster resource quota just leverage the admission webhook. Also, it is only responsible for admitting compatible resource request, while not updating any resource usage as a built-in resource quota admission does. So the design idea here is just to rely on both the admission and the controller of the built-in resource quota to further evaluate the compatibility of the resource request and update the usage accordingly. So yeah, here is a diagram of the architecture overview about Kubernetes with cluster resource quota. So it also shows that the control flow of how cluster resource quota works with the built-in resource quota when there is a pod is created. So here, let's assume that the class resource quota instance has been created for one tenant, and all the managed resource quota instance has been created in each of its namespace. So when a pod is created by the tenant, so the request will firstly go through the out of tree admission webhook of class resource quota, and the class resource quota will evaluate the resource compatibility based on the quota and the current usage, and it will either deny it or just allow it. So if the request is allowed by the admission webhook, the request will go through the entry resource quota admission, which will admit and update the resource quota usage. So which it's just a built-in logic. So after that, the resource quota controller will reconcile the quota and recalculate the usage to provide the source of truth. This step is also just built-in logic. And after resource quota have just completed the work, the class resource quota controller will keep watching for all the managed resource quota and just syncing and aggregate the usage of this of each resource quota under all the managed namespace. So yeah, there is some advantage or disadvantage in terms of this kind of design. So yeah, the advantage is like it effectively avoid the contention in usage calculation and update from both a class resource quota and resource quota. So yeah, that is compared to if the design of cluster resource quota just inherit what the resource quota admission does. So there will, if the class resource quota also work for like a usage update. So yeah, there will be contention in terms of usage calculation and updating. So yeah, that being said, this kind of design also simplify the class resource quota admission part. So the admission is easy enough. Just do the compatibility evaluation and just either admit or reject. So yeah, in terms of the disadvantages, so oversealing is possible because the asynchronous model of the listen and watch of the CRD update. So because we rely on the usage update, which is aggregated and synced from into the class resource quota status. So since it's asynchronous, so if some ongoing request has not yet been persist or has not been updated into the status of the class resource quota, and if before that there is some other admissible request comes in, so there will be resource quota oversealing. So yeah, that's pretty that's kind of no issue here. So we try very hard, and we can have some alert, or we can introduce extra allocated field to just aggressively to just prevent the oversealing. But I think it's just a trade-off between either oversealing or underselling. So yeah, so much for the cluster resource quota itself. So now let's take a look at how kubezoo leverage this cluster resource quota feature. So inside the tenant spec, so we add a new field for specifying the cluster resource quota. So whenever a tenant instance is created, tenant controller will create a cluster resource quota instance in the kubezoo API server, and cluster resource quota controller will take over the rest. And as we mentioned in the previous slides, something like it will create one resource quota in each of its managed namespace under this tenant. So yeah, similar thing, and reconciliation handling will apply to the update and delete events for the cluster resource quota spec in the tenant. So here, so much for the theory about this new feature and status update. So yeah, now we're going to have a quick demo about this new feature.
Do you want to pause here, see if anybody has any questions?
Why not? Yeah, we can do that. Yeah,
this is Fei. I got a question. So can you go back to your previous slide? How do you distribute the sync hard limit? How do you distribute the limit to all namespaces?
So basically, since the cluster resource quota controller will create one resource quota in each of the namespace. So yeah, the namespace will be we identify the namespace by labels, and
do you have a CRD definition in your slides, or maybe that can explain my? So basically, you need to specify each namespace has how much quota in the tenant spec, isn't it?
Oh yeah. So yeah, for the hard limits, we just specify, just inherit whatever the limit in the cluster resource quota. So yeah, I didn't prepare the spec, CRD spec in the slides, but I think the demo will show that. So you can think.
So you just specify what is the limit for namespace, and if you have n namespace, it's going to be the total quota would be n times the hard limit, is it?
Yeah. So basically, let's take an example. So cluster resource quota have like 2 CPU and 2 gig of memory, right? So that means in each of the namespaces, it will have like 2 the same, exactly the same. So
okay.
2 core and 2 gig of memory.
Okay. So
the total quota will not be the sum of that. So the cluster resource quota admission and controller will just prevent it goes beyond more than the higher limit. Yeah.
I think we just use the resource quota to collect the usage in each namespace. We actually didn't do any limitation.
Sorry, I just want to make it very clear, because so if people want to use cluster resource quota, they want to have a, let's say they want to put a hard limit for tenant. How can you do that? If they want to put a hard limit for tenant, how can you do that? If you want to duplicate every namespace with the limit, can you do that basically?
Hard limit for, I think so, but it cannot be granular. So for each namespace, it will just all the namespace under the same tenant will be have the same.
Yes, but then you have a problem, right? So let's say, regardless how many namespaces you created, if I want this tenant only have N CPU, Y memory, even so, whether you create one namespace or 1,000 namespaces, they share the same quota. Can that be done?
Yeah. So we have 2 level of check, right? So resource quota. So cluster resource quota will check and prevent this kind of all the requests will not go beyond the N core and Y gig of memory, which is kind of like shared pool on all the namespace under this tenant. So, but we don't prevent, like, if the tenant just want to create all the resources within one namespace, it's also okay. So as long as both the limit of the class resource
So
quota.
basically, you
And
have
Can I-
global limit, which is the sum of the namespace. You also have a way to tell each individual namespace what's the limit, and the individual namespace limit we are going to be duplicate for every namespace you create.
Yeah.
But you have a bigger cap. Okay.
yeah,
So sorry,
Yeah.
let me chime in. I think the demo might help people to understand this better, since we have some real specific data, right, to show how this works. Maybe we should go to the demo and then we can answer question from Fei.
Yeah. Please.
yeah, I think demo will illustrate that. Yeah, I believe Ryan has some question.
I was just gonna, I guess, reiterate my understanding because I think it's similar to how we handle it for HMC. And so, yeah, Fei, essentially they put a resource code on each namespace, and then anytime that changes, they add it to the global. So you have that global status, and there's an emission controller on that. So there's a delay, but I think that's my understanding of how it works, right?
Yeah.
Okay, I understand. I understand. Yes.
Yeah, I think yeah. So any other folks have any question?
So, but that means within the tenant, namespace can content for the quota, right?
Mm-hmm. Yeah. Content, you mean contention?
Yeah, content. I mean content for within tenant, because so apparently each namespace have a kind of a little bit bigger quota, right?
Mm-hmm.
You want this class scope quota is fully utilized, then you have to each namespace a kind of little bit bigger quota. Then these two namespaces may contend for the quota because the A may get more, namespace B may get less, depends on the usage.
Mm-hmm. Oh yeah, I got your point. So if the tenants like trying to create resources in two different namespace,
yeah,
and
different namespace within the tenant, they have contention because each one will have a definitely bigger limit. Otherwise, the class scope limit is going to be waste. Then one namespace may get all resources to reach that class scope namespace quota. Then the other namespace cannot be created. Anything, right?
Mm-hmm.
You can have.
Yeah, I think like theoretically, yeah, it's possible in some like extreme cases. So yeah.
Okay, then let's go ahead with the demo. So it's pretty much is a configuration issue. So something that you probably can mitigate with a proper configuration. But anyway.
Mm-hmm. Yeah. Okay, yeah, let's take a look at the demo here. So I sure. So yeah, let me just I prepare recording here. So yeah, just make sure everything goes smooth. Yeah, let me just start the recording. And so yeah, after the thing is set up, so we can see that we have two contexts here. So one is for the backend API server, and the other one is for Kubzu. Yeah, and in the next step, we're going to create a tenant. So yeah, after we apply that, we just share what is included in the tenant. So we just name it with 6 ones and with 2 CPU, 2 GPU as a memory. So then let's check the status of the cluster resource quota. We can see that. Yeah, we can see that we have. Let's go back to a little bit. Yeah, we can see that we have 2 CPU and 2 gig of memory has been specified in the spec, and in the status, the usage is just also the usage is 0. And in the next step, we are going to download the kube config for the specific tenant. So yeah, we're going to take a look at whether there's anything in the kube config file. Yeah, so yeah, let's just take a look at the resource quota from the tenant perspective. In the default namespace, the resource quota, yeah, which is the same as what we specify in the cluster resource quota. And here we're going to create a pod, still from the tenant perspective. Yeah, here's a pod with one CPU and 1 gig of memory, which is under the cluster resource quota specified in the spec. So yeah, we can see that the pod has been created successfully, and yeah, the pod is running now, and then yeah, we're going to check the quota usage. Yeah, as you can see, in this resource quota in the default namespace, yeah, the resource quota usage has been updated. Yeah, we also take a look at all the quota from the perspective of the backend API server. So yeah, as you can see, which might answer Faye's question. So each of the namespace will just get the same like hard limit, with the same as specified in the cluster resource quota spec. Yeah, in the next step, we're going to create another pod in a different namespace. So yeah, we are going to create a namespace called test and create a pod under the namespace. So yeah, we can see that in this request, it has 2 CPU and 2 gig. So if we just take a look at the resource quota under test namespace, so it should be admissible, but it will be rejected by the class resource quota because if the pod is created, the total like usage will go beyond the hard limit of the class resource quota. That's why it will be denied. So yeah, you can see that the quota has not yet been updated. And from the global view, right? So for all the namespace, so yeah, there's no change to the quota because the second pod request was rejected. Yeah, same view from the backend API server perspective. So in the next step, yeah, we're going to like show you guys how the resource quota, which is a customized resource quota, collaborate with the cluster resource quota specified in the tenant spec. So here we are going to create a customized resource quota on one of the namespace under the tenant. yeah, before we do that, we just delete the first pod we created. So make sure everything is empty and delete it. It's just a brand new test bed. So now all the quota has been updated accordingly. Yeah, we prepared YAML for create resource quota. So it has a hard limit for 1 CPU and 1 gig of memory. And then the tenant will apply this resource quota, so which will create the resource quota under the default namespace. So yeah, we can see that under the default namespace from the tenant perspective, yeah, we have 2 resource quota there. Now we're going to create a pod request. So which is beyond the class resource quota, or which is beyond the customized resource quota, but under the class resource quota. So you can see what will happen. So here, if you look at the error message, so it's not the error is not raised by class resource quota. So that means class resource quota just admit this request, but the resource quota admission component just rejected because it the specific the customized resource quota, or the request just goes beyond the customized resource quota we just created. So yeah, I think that concludes my demo, and yeah, hope it just properly explained the question Faye has. Yeah, so that's it about the demo.
Yeah. Okay. Yeah, I kind of understand. So, but why you still have to, by default populate or quota for all the namespace that could be zone that generated for each tenant, because then you can get a usage. You don't have to account the usage yourself. You can account the usage for every namespace. So is this the case? So if you use so is it required? Every namespace has to have a quota. I think so. Every tenant, every namespace in the underlying Kubernetes needs to have a quota.
Yeah. So yeah, we are going to take a look at the extreme case.
No, not extreme case. I'm just saying that. Okay, is that possible for any of your namespace, let's say, to remove the quota? I don't think so.
To remove the quota? No, you mean the, yeah.
Can you go back any of the demo? So each tenant at least will have a 4 namespace, default Kubernetes system, whatever. So can the Kubernetes system that namespace doesn't have the quota? It has to have a quota.
Yeah, it have to, and the class resource quota controller will keep reconciling. So if someone just trying to delete it, it will be just recreated.
Okay. So yeah, because you have to have a quota, otherwise you don't have an effective way to track the usage, because the quota controller, the building quota controller will do the usage calculation. Okay, gotcha.
Yeah.
So in terms of the roadmap, any other major features or things planned?
We are still working at the multi-tenant DNS and the access control for multi-tenants. We found some access leaking issue, and we try to build a more security Kubernetes solution. And in that solution, we will support the service accounts and the RBAC role-based access control to support the we will define a tenant finding object to help us improve the access control. I think that's the two of the major feature we are working on.
Okay.
So we hope a lot more community users like to use the Kubzu, so can send us more input and feedback regarding our next steps. So depends on you guys, Jim and Ryan, Faye, you guys help to evangelize, this is a cool thing, right, to the community better, so we can have a more audience.
Yeah, but I think that the entire cluster scope resources can be independent of Kubzu, right? Even
Yeah,
so,
exactly.
Ryan, if you look at their design, I mean, HNC can use it.
So
That's one
yeah.
of the use case.
I mean, we implemented the exact same thing in I'm assuming mostly in HNC, so that's already there. But yeah, it seems like it's a pretty similar design.
So did you do that? So every namespace we inherently got the full class scope quota by default. Then you let people to individually select the override the default setting. Is this your design?
So Adrian and I forget who else was on the team at that point, but they rolled it into Anthos for it's the Google HRQ, and then they backported it to HNC not that long ago. So yeah.
Okay, but from the design perspective, do they share the similar stuff?
It's pretty similar. I was actually looking through back in the code to try to figure out exactly what we're doing. And so yeah, like essentially there's it, but since we're hierarchical, we know all the child tenants, and so we manage it, and so we do the calculation up front, so we can make the emission webhook.
Yeah, I think the funny part is the key funny part is they don't do the usage packaging in any of the internal memory stuff, internal cache. They just leverage the building quota stuff to do the usage calculation. So which coming from API server should be accurate and synchronized from an API server perspective. So
Yep.
the trick is you have to give individual namespace as a cluster scope limit by default. It has because one namespace can use all. You should allow that. Then, but if people want to do final granularity control, you can override the namespace with the final granularity one, right, Lintong? I understand. If I understand correctly, that's the purpose of the design. Lintong, am I right?
Exactly.
Yeah. Sorry, I'm muted.
Yeah. I think that's some. I think that design makes sense in the sense of in the case from the management perspective and the simplified design. I mean, we admit there are risks. that can be wrong. Cool.
Yeah, this is good. Thank you for the update, and certainly looking forward to some of the other features you mentioned. And we will, we'll post the recording on the channel, and we can kind of publish it there.
Thank you, Jim and team.
Yeah, thanks for having us again, and thanks for the feedback.
Absolutely. All right. Yeah, it doesn't look like we have any other topics to discuss. So if with that, we can just conclude the meeting.
Oh, by the way, you guys going to KubeCon this week?
Yes,
Next
I
week,
am,
right?
but I think most others, I think Ryan, so you're shaking your head, so you're not traveling, right? Or Faye, how about you?
I won't.
Okay. Yes, I'll be there. I'm there Sunday through the following week. I think Saturday, so pretty much all week. Yeah.
We tried. We haven't made a decision yet. People are tired and sick, so we probably will skip this time. But good luck to your session, Jim and the folks.
Yeah.
Thank you.
All right.
Good to see
Thanks,
you guys.
everyone.
Bye-bye.
Bye-bye.
Thank you.
Yeah, thanks. Bye.